Good morning, everybody. Welcome to the Thought Bridge event. As many of you probably know, the Thought Bridge is an event to bridge theory and practice. It's not about thoughts only, it's also about activities. And the activity here is to give you, as practitioners, new insights into what goes on in research, and on the other hand, also for us as researchers to get to know more about what is going on in practice. As you probably know, the Institut für Unternehmensführung has a long tradition in close collaborations with practice, but still I think it can be improved. And the Controller Institut is a platform with a long tradition in mediating this collaboration between theory and practice. And I would like to thank the Controller Institut and Dr. Rita Niedermeyer for these long years of being a promoter and innovator in improving the collaboration between our university and practice in financial leadership. In a way, you could ask, isn't it quite a natural thing to have a collaboration between theory and practice? But I think it's not so natural, and I think for us as coming from performance measurement, I think it's very easy to understand why collaboration is not so easy, because we are measured along very different performance measures. I mean, in practice, you as companies are measured in terms of economic success with measures such as profit or market capitalization, whatever. And we are measured in terms of our newly generated insights, in terms of our publications in top journals, and this is not the same. But we think that both sides can benefit from coming across the bridge and talking to each other even more than we already do. And to make you probably cross the bridge and us, I mean, for us, it's very clear what we hope to get from closer collaboration with companies. I think that our research can greatly benefit from your insights, from your stories, from smart people like you who tell us what is going on in practice, and this will make our research much more creative and innovative. And what you maybe would not think what is the most important thing for us to do our research is data. And for us, your data is the lifeblood of our research. And you would not believe what kind of data we would like to have, all kinds of data, financial data, non-financial data, old data, outdated data, whatever. We love data. And if you have anything where you think, well, there could be some data that could be interesting from a research perspective, just let us know, and we will be, next day we will be in your office and try to make sense of your data. The best case for us is if you don't understand some data and we can somehow help you to understand it. So data is something we always love to have. But you may ask, what can we offer to you as a university and as a department more particularly? I mean, your first idea probably will be students, right? So the first thing you will expect is is to deliver good students who are prepared for practice, and I think we do that. But what else happens in research? So I would like to say a few words on our university, WU. WU consists of 11 departments, as you probably know. It's 2 law departments, 1 languages, 1 economics, 1 socioeconomics, and 6 in business. And our department, the Department of Strategy and Innovation, is one of these 6 business departments. I've been the head of this department now for almost 15 years, And we are now around 100 researchers at our department. And of course, researchers and teachers, but today I'll talk more about the research. These 100 researchers at our department are organized into 9 institutes with 10 full professors, and each institute is about 10 to 15 people on average. And the main focus of our department, as you may know it, is of course still in management, accounting, and corporate governance on all those things. But I think the particular thing about our department is not that we wanted to become the biggest department in management accounting, but that I think our main idea about our department is that it may be more valuable to have complementary expertise. For example, the original idea behind our department was to have this tension between, let's say, the more efficiency-oriented view of traditional management accounting on the one hand side, and innovation strategy on the other hand. And maybe the original idea behind our department is to create new insights in this tension, which is also, I think, very, very common in practice, this tension between efficiency, efficient management on the one hand side, and creating variation, creating new insights by creativity, and how to organize, how we can bring both together in fruitful ways. But I do not want to talk about these two original building blocks of our department, but more about a new building block. And now I would say we have 3 main building blocks in our department. And the third one is, I would call it judgment and decision making. And here again, from the very beginning, we had on the one hand side a new colleague who's coming from economics and does judgment and decision making from more economic perspective. But now we also have, and I think that's extremely valuable, we have a new colleague from psychology, because as you all know, decision making and judgment is not only about rationality and about like things like game theory, multi-period thinking in complicated contexts, but it's also about a lot about psychology, also in business firms, I guess. And so we created a new tension, let's say, between more, let's say, traditional decision-making, economic decision-making, and behavioral aspects of decision-making. And here we have the new Institute for Cognition and Behavior, which is headed by Professor Susanne Fiedler. And as part of that new initiative to focus on judgment and decision-making at our department, we also have 2 very newly hired assistant professors, and you will get some insight into what they do in their research. And these 2 assistant professors are Magie and Christian Haas. And as you can see already from the title, it's about artificial intelligence and machine learning. And I think these are very, very well-known and new and timely and important developments in practice, and of course also in research. And when I maybe talk about our first, I don't want to, I mean, Maggie will do that much better than I could do it. But what the title already reminds me is what a finance professor of mine told me when I was a student. And he said, and I still remember that, he said, when your decision turns out to be a good decision afterwards, then you can easily say, well, it was my intuition, and I just had the intuition to do that, and it turned out to be good. But if the decision turns out to be bad, then you should better have some Excel sheets and data to explain why you made a bad decision. Because otherwise, you will probably not survive that, right? And maybe we have a very similar problem in terms of artificial intelligence, because I think as a main characteristic of it is that artificial intelligence creates insights, recognizes patterns, and creates a basis for decision making, or makes proposals for decision making that are not 100% understandable, which are maybe something like human intuition is maybe more like machine intuition, right? And it's very difficult maybe later on to explain, if it goes wrong in particular, why you made this decision. And so AI accountability is I think a very, very important topic. And the next thing is, well, while we as humans have some norms, how we make decisions and what we consider fair decisions, machines probably do not have these norms. Think about insurance company. When we charge maybe more, I mean, if young people, let's say for car insurance, and it's quite common that young people have to pay more than older people because the likelihood that they have an accident is higher, right? So that's considered probably fair, right? But then if you think about life insurance and if certain habits or certain things you do in your life have an impact on how much you pay for the insurance, and maybe you have a fitness tracker on your arm, and the data that it generates have an impact on how much you have to pay for insurance, then maybe not everybody would say this is fair. And this is also, I think, a very, very interesting field, and Christian Haas will talk about that. Then we'll have a discussion. If you have some ideas or questions or remarks, just use the chat function and post it. Or you can, of course, you can do this already during the talks, but then in our discussion, you can also just unmute and ask a question. And then, of course, another highlight is our the insights that Carsten Bork will provide on practical appliances of artificial intelligence and machine learning in controlling and finance. And then we have a final discussion, short wrap up, and that is it. So we start first with Magie. Thank you for contributing, and let me just say we are very proud to have you as a new colleague at our department. So stage is yours. Thank you. Welcome.
Thank you, Gerhard, and good morning from my side, everyone. I have the distinct pleasure of, in 10 minutes, explaining everything you need to know about AI explainability, data evaluation, model evaluation, and workforce development. So strap in. This is going to be a long ride. I think the best way to start is possibly thinking a little bit broader. Let's just start with an analogy. There's a fairly famous case from computer science, which is called the case of the killer robot. It's something that we use in computer science ethics classes. It started out as a, let's say, 25-page document written in the style of newspaper articles and interviews. It's now a 200-page document reporting on an incident where an assembly line robot killed a man when the robot he was operating malfunctions and starts waving its robotic arms quite violently. In fact, the robot hit the man, threw him against the wall, and killed him instantly. Now, this is pretty sci-fi, or at least it was, but it's actually, when you think about it, quite become reality, the idea that a robot could possibly kill a human. And in fact, we've seen it in cases ranging from Tesla self-driving cars to food production, but as well as with the military, if you're thinking about self-armed drones. So the question I'm going to ask you to consider a little bit is, who is accountable? So when a non-sentient agent, like a robot, kills a human, how can we understand, how can we take action and enforce accountability, enforce responsibility for that death? And first, of course, it's always who is actually the accountable agent. So is it the person or the engineer who programmed the code? Are they responsible for the malfunctioning of the robot, which turned it into a killer robot? Could it be the interface designer? If the interface of the robot design was not intuitive, then is it their fault that the robot has turned into a killer robot? Is it the tester? There's literally a person on an engineering team as well as a design team whose purpose it is to find these problems. So is it their fault? Or does accountability rest at the higher level? Is it the bosses of any one of these individuals? So the head of the team should be the responsible agent, although if we're talking about manslaughter, right, it's pretty important. We don't necessarily want to enforce accountability where it doesn't belong. Another sort of interesting and weird question is, if a robot kills a human, to what degree are they responsible for their own death? Generally, a robot or an agent is controlled by a human. There are not many robots that are currently in production or in use that have no humans in the loop. So to what degree is the victim actually responsible for their own death? Or is it the CEO, right? Where does the accountability rest whenever something goes so incredibly wrong? And since it's morning, I'm going to now dial down the abstraction and let's talk about something that might actually be a little bit more relevant for the finance sector. AI, we know it, is already behind a lot of automation processes, a lot of decision processes, and that's across not only the financial sector, but many, many more. So let's use two examples from recent insurance news about responsibility. It's the same scenario. Who is responsible when you have an AI decision-making agent deployed in your insurance sector that interprets that Jews burn more candles indoors, which is a high-risk behavior, or that Black athletes have lower starting IQs than their white counterparts, and thus offer these types of classes of people worse conditions, including higher housing premiums or lower health insurance payouts. These are two actual examples from the US currently, but you can see how the case of the killer robot and unfair practices across the financial sector actually are a lot more linked than you would think, because the question does come back to who is accountable? Why is that the right answer? How can we make this transparent? There are a couple of areas of tension on the data side, but also on the model evaluation side. Let's talk through the data side a little bit first. What we know is in data that there are known and unknown correlations. For example, if you know a person's zip code, you have a very good proxy for how wealthy they are, but also how healthy they are. Likewise, if you think about another correlation that exists in data or is a proxy in data, if you know which institution a candidate graduated from or that issued their degree, you also have a proxy for the quality of your candidate. These are correlations that just exist inside of your data, which says that your data is probably biased going in. Another problem on the data side is that what we want to do here is take social phenomena let's talk about gender, for example. Is gender binary or is gender multifaceted? We basically come down and agreed so that there are more than two genders. If you're taking sharp rules, like what you need for powering an AI agent, you're taking away from what is a social phenomena of something that's actually a little bit fuzzier, and you're applying these rules to fuzzy data in a sharp way. That means that you're enforcing a way of understanding in your data. You're making it conformant, even though its natural state as a variable doesn't necessarily have 100% agreement, which is problematic on the data side. The other problem on the data side is actually kind of us. There is a little bit of a trouble spot between the output of your AI and the data and our cognitive limits. Why do things happen? Well, it's not always that from the data you have an extremely complex model that shoots an unaccountable outcome. It's often that humans just don't understand what the outcome is. Now, one thing you can say about AI is that the output is always going to be rational, even if it's not explainable. The trouble with machine rationality is there's potential for AI to bring forward these extant integrated injustices inside of the data because we are assuming these natural laws, these hard borders, and these known and unknown correlations that don't exist. Applying these natural laws, these mathematical formulae in the up top of these social constructs. And then that difficulty is magnified specifically in the use case of business financial cases, because in the financial sector, we have to think about the business as a stakeholder here. There's short-termism that we have to deal with, right? There's stakeholder financial value that's really important to the business model, not humanist values of having a fair, accountable AI. That all of this is sort of this murky little mess right now, and it's an explainability gap. And that explainability gap is actually an AI trust gap. Then the trust gap is a hesitancy to use AI or utilize AI to handle all of these decisions because there's no confidence right now. And that's why and how AI can be perceived to be destructive, particularly when you're thinking about what we call these black box models. But we should also remember that black box models are not the only type of models. In fact, on the model evaluation range, some are quite open and clear. And that's because there are trade-offs in accuracy, interpretability, and explainability. If you're thinking about the spaces of linear models, for example, linear models we like to think of as exact explanations or approximate models, as opposed to these more neural network styles or classic black boxes. Those tend to be approximate explanations for exact models. So we have this trade-off that we need to really think about. Do I need my model to be highly explainable so I can explain both what the variable represents and its importance to the model performance? Or do I need something that's interpretable? And that's the ability to determine a cause and an effect from a model. Because this exists, and this entire space is exactly where we are currently doing our research. Just a couple of thoughts to wrap up, because I realize I present more of an agenda than I'm presenting a particular piece of research. If this problem feels intractable, don't worry. In fact, people who are much more fluent in these problems, for example, Googlers, computer science faculty at Stanford University, they have not yet actually figured out how to solve a problem of accountability and fairness in AI applications. And I would leave you with this question and link it back to this most important part. if we are going to have AI that we can trust in our processes, what we need to be aware of is what a computer can do well and what a human can do well. What a human can do well is an analogy, right? A human can transfer knowledge. A human can look at a case of a killer robot and understand how to better prepare students to apply AI in their careers. So handing over to Dr. Haas, the question remains, how should and could accounting education incorporate adaptations to train students, but also understand our larger social picture and be aware of the values that we have in order to have these fair, accountable AI?
Thank you very much. Thank you. Our next presentation is by Christian Haas, and he will give us some insights into fairness in automated decisions. Christian, thank you.
Thank you, Gerhard. I hope you can see my full screen now. It's a pleasure for me to be here this morning, and I'm going to continue where Maggie Hall left with the discussion of workforce development. Specifically, I'm going to talk a little bit about fairness, discrimination, and bias that we see can happen in these automated decisions, and discuss a little bit why they happen, where they are coming from, what some technical, especially technical solution problems are, solution approaches are that we have nowadays, and what some open challenges remain in this particular research domain. So, starting with the general discussion, why we increasingly look at these fairness, bias, discrimination issues. We all know that in the last couple of years, we saw a vast increase in the adoption of machine learning and artificial intelligence. Many companies do it, many people adopt it. And one of the reasons that it increasingly gets adopted, besides having access to more data, etc., and having trained data scientists that work on these, is what's called the democratization of AI. And one of those drivers is it becomes increasingly easy for pretty much anyone to develop a machine learning or even a simple artificial intelligence model. Nowadays, there are low-code or no-code tools available, nice graphical user interfaces. You essentially point them towards a data set. You tell them what you want to predict. And in the background, after one click, they essentially look at many, many different models. We saw it on one of the previous slides. There are different types of models, neural networks, support vector machines, linear models, etc. It tries dozens of combinations. It tries to tune the parameters of the models. And in the end, those tools essentially give you an output, give you a prediction. And in many cases, this is great, right? Because it opens up the applicability of these machine learning models to a vast amount of users. On the other hand, it can also come with downsides. And people call it that this democratization of machine learning, democratization of AI is a double-edged sword. It's a double-edged sword because, of course, we can create downsides. We can create bias, fairness. And I'm going to talk a little bit about that in the next couple of slides. Actually, the discussion that we see nowadays in the research and practitioner community about discrimination and bias is kind of like an extension of a discussion that we had in data science in general over the last 10 years. Because when data science became popular, especially when these tools become more usable, we had the small but very vocal community that said we actually have to be aware of a potential danger zone, a danger zone being that we have people creating these machine learning models, these AI models, and applying them for their own business processes or use cases, but they don't actually understand what's going on underneath the model. They don't actually understand what they need to be aware of when building, training, and then using these models. And in a way, this is, again, what drives these fairness and bias discussions. So let's look at a couple of examples where this can happen. Over the last 2 or 3 years, there are a couple of high-profile cases, highly visible cases that have been discussed in major news outlets across the world. And as you can see just from the names Amazon and Apple, even major companies are not proved against these potential biases or discrimination in their processes. So on the left side, you see Amazon tried to create an AI or machine learning tool for hiring recommendations. So essentially take data like CVs and resumes of candidates and give me a decision, basically, which candidate I should interview or essentially which people I should hire. After it was in beta testing and published for a couple of days, it was quickly shown that it was biased in the way that it disadvantaged women. So women were much less likely to be suggested by this particular tool than men. And to the best of my knowledge, in the last 2 years or 3 years where this happened, we don't actually see an update on this model. They took it off the market, and maybe at some point we'll see another iteration. Another one, Apple. This is also really interesting from a finance perspective. So Apple Card essentially used a machine learning algorithm. I think it was in combination with Goldman Sachs, that essentially gave people a credit line. So automated decisions that said, you can have this much credit with us. And after a while, people started tweeting, hey, I have joint bank accounts with my wife. My wife makes more money sometimes. My wife has a better credit score, but the Apple Card actually gave me 10 times the credit limit. And my wife has a much lower credit limit. Why does this happen? And this actually led to a very interesting conversation that comes back to explainability. So the customer support essentially said, we cannot really explain, we cannot really tell you why this happened, but we can assure you that our algorithm is not discriminated. And that is a dissonance, right? Both things cannot really be true. If you cannot explain why this happened, how can you show that it's not discriminating against certain individuals, against certain groups? So the thing here is, if this happens with these major companies that have highly trained data scientists working for them, what can happen if we see an increasing adoption of machine learning, of AI tools for, let's say, lay users, non-trained data scientists, essentially? We probably exacerbate this really, really harshly. So we need to look at skilling up. We need to look at workforce development, making people aware that these bias and fairness issues can actually happen. Of course, besides the financial industry, we also see use cases where this really can have an impact on your health or on your life. And one of the most well-known articles, research articles in fairness in automated decisions, in Science, one of the major research outlets, essentially looked at the bias of an algorithm that was used to determine healthcare budgets in US hospitals. And what they showed is, involuntarily, what the algorithm actually did is it allocated less money, less budget for Black patients. So what happened, through some very, very specific technical reasons, what happened is, at the same level of predicted risks, Black patients were actually less healthy than white patients, and that led to this really bad discrimination in the algorithm. And I say involuntary because the creator of that algorithm actually now works with the researchers in California to make sure that in the next iterations, this racial bias can actually be counteracted. Artificial intelligence, ML models, have also been used to predict crime, how likely it is that you essentially commit a crime. And again, these algorithms have been shown to be biased or discriminating against certain minority ethnicities, right? So we have these really high impact decisions that potentially are biased or unfair. So just really briefly, where does this unfairness come from? Where does this bias come from? And there, as you can see here, there are many different aspects in a decision process that can bias the outcome. Frankly, in many cases, it is actually the data that is used, the data that are used to train your machine learning models, to train your artificial intelligence models. So the data can be collected based on biased existing processes, right? It can not be representative of the actual population. There are many different types of biases that can impact your decision. And of course, if you train your algorithm, the algorithm essentially looks for patterns. If the patterns themselves are biased, the algorithm, the ML AI system will pick up on it, and it will use those patterns to predict whatever outcome you want to predict. So essentially, if you're not careful, you're perpetuating these biases, these stereotypes, this unfairness in the future. Really briefly, from a technical perspective, what have computer scientists, data scientists essentially focused on in the last couple of years? They focused on trying to mitigate these biases in different steps of the decision process. So I just told you that input data is often biased itself. So why don't we try to adjust the input data that we use to make it less biased, right? And one of the initial ideas here is, well, if I don't want my algorithm to discriminate based on gender, to discriminate based on race or ethnicity, why don't I just leave those variables out of my training data, right? Why don't I just not include these when I train and build my machine learning model? Unfortunately, and we heard that earlier before, it doesn't work because there's so many hidden correlations in your data set that the algorithm, the predictions that are generated can still be biased. So there are many different approaches here, synthetic data, anonymized data, transformed data, that essentially try to make sure that the algorithm itself, your machine learning model, doesn't even pick up on the biases in the first place. Of course, there are different alternative approaches. You can try to update the algorithm itself by saying, don't just focus on how accurate your predictions are. Also try to actively make sure that I'm not biasing it against certain participants. So these are more technical options. Of course, bias and fairness is also part of a socio-technical or socio-economic system. So there are many different aspects of fairness and bias that make the overall solution here much more challenging. And this is actually where I want to kind of like wrap up some open challenges that we see. On the one hand, multitude of fairness definitions. I can tell you that nowadays there are dozens of different fairness definitions, and some of them are incompatible. So what might be considered fair in one setting might not be considered fair in another setting. And trying to find a universal fairness definition is actually really, really hard. You see a screenshot from one of my papers actually here. It's just a couple of fairness definitions. As I said, there are dozens of them. But another discussion that comes up is, do we look at treating groups fairly? So for example, women should be treated equally to men and blacks equal to Asians equal to white? Or do we look at the individuals? Should each individual be treated equally? And there are different definitions, different ways that we can try to tackle this. But again, there's always a context specificity in here. On the other hand, we see regulatory efforts that try to combine questions of fairness, of bias, of accountability, of explainability into a regulatory context. The European Union, for example, right now discusses certain regulations that try to make sure that these biases, these unfairness doesn't actually happen. So in the next probably 1-2 years, we're going to see some interesting regulatory frameworks coming up as well.
Thank you. So first, I have a question that is probably one very interesting aspect of both of your presentations. So the question that I ask myself is, what are the skills that we need for future financial leaders, and also, of course, for not only for the leaders, but also from an educational perspective, how can we best equip future people in the finance function? Is it? I mean, as far as I understood you, it is not so much only about the statistical and technical skills in terms of applying artificial intelligence and machine learning things, but more the interpretation of the data. So what would you see is the role of the finance function here? I mean, we will not be the experts in developing those algorithms, but is it the interpretation? Is it a kind of let's say translation of what the machine does to daily business? How do you see the role of financial leaders of the future, and what skills do you think they need?
When I teach a class, my students always get so irritated with me because I make a strong point that it's no longer good enough to say, okay, well, I'm a finance person and I'm going to know everything about finance. And then there's an engineer or an engineering team and they're going to know everything about the code. And then there are going to be other levels of people that we interact with, controlling or governance and any other function, and they're going to know everything they need there. It's not good enough anymore. If you continue to practice siloed education, you're going to continue to come up with solutions that are only as good as your frontier. So the fundamental thing for me is expanding that frontier. If that is on upskilling, taking current employees and giving them a broader horizon, or if that's on really your introductory lowest level graduate student who is just starting today. If we don't expand the space that they see as relevant, there's no way we can reasonably expect that a student, eventually tomorrow's leader, is going to be able to make a high quality or a wide reaching solution. So it's really on us in a lot of ways to make sure that we do a better job of expanding what that horizon looks like.
Mm-hmm. Yeah, and following up on that, I think this interdisciplinary or cross-domain perspective and being aware of what ML and AI can do, but also can't do, I think is a really important perspective, because in a lot of discussions that I have is machine learning, AI is often conflated with deep learning and neural networks, right? These traditional black box models. But as we see, as we saw in one of those slides, there's a wide range of models that can fit somewhere between your standard linear regression that might not work that well in terms of predictive accuracy and those black box models, right? So raising the awareness of in what processes machine learning AI makes sense, what it can achieve, but also what things you need to be aware of in terms of applying these predictions. Like, do you have to be aware of any regulatory concerns? Do you have to be aware of potential biases that you might never have thought about? And just being able to talk with different experts, with a data scientist, with a computer scientist, with a business domain experts, etc. Just raising this awareness that this is a holistic process where everyone needs to work together to create like a working solution, as Maggie Hall just said, I think is one of those really important aspects, because the tools themselves, they're just getting easier. It's just going to get even easier to create those models, right? And not everyone is going to be a statistical expert, but knowing what you can expect from those models, knowing where you should and can apply this, and what to look out for, I think is one of those really important ethical topics as well that we need to focus on.
Mm-hmm. Okay. I have two questions in the chat, and maybe both questions have something in common. I mean, all of us use to some extent artificial intelligence already in our everyday life. We trust the proposals on music from Spotify. We trust the proposals of Google and many other things, and we think that works quite well. But we do probably not trust in business, we do not trust the proposals of artificial intelligence, and probably it is because of those biases that we expect in this data that we do not understand. I mean, what do we need? I mean, do we need different kinds of experts in the future who learn how to deal with these proposals and just use them as one more basis for decision making and judgment? Can you probably comment a bit on that?
I think when we're talking about the trust gap, there are two directions for it. Looking at the first question and speaking to that a little bit, one of the reasons that we don't trust AI is that I don't think that we as a unit necessarily believe that we're focusing AI on the right questions. So if you're talking about automation and controlling, I'm aware of some research that was conducted with a large German pharmaceutical firm looking at forecasting and controlling. And what they found is pretty consistently there was a bias in the controllers. The automated process would have something that was quite accurate, and they couldn't shrink the delta between the controller and the AI. And it's consistently coming back to that. How do we make better financial decisions when we know that our people are not going to take that better advice? Well, if I don't trust the AI in the first place, if I don't think that it's solving the right problem, if I don't think that it's taking into consideration, if I believe myself more, right, humans will trust themselves more, then it's pretty obvious that we're going to keep bumping up onto that user side error as far as it goes. So that would be my side on at least the human interaction there.
If I can take also the point here, especially in the planning area, planning in many corporations, planning is a kind of a negotiation process. So it's not the point that the truth is always clear and whatever. The people, they are, sandbagging and stuff like that. They are looking for funding and flexibility throughout the year in terms of budgeting on a yearly basis. And I think one big topic is here, if they just get judged and allocated by AI, they have a kind of a feeling that there is no much room for their own decisions over the year, and they have to at least argue the whole time again any machine learning or finance machines budgets that will be created on an automatic way. And this is, I would say, one of the main reasons. It's not the point that the people don't think AI is not capable to deliver a good point of view, how future will trouble down or come down into financial figures. It's more the point to lose room of navigation, to lose or to have at least a higher effort to argue against budget which are automatically created. And I think this is one big topic why people will not accept in the first place an generated budget out of the machine. Yeah.
Maybe just to follow up on that really quickly, I think part of that, and this is an open research topic, like in which processes and which applications would humans be willing to trust an AI as compared to when they are not willing to trust an AI. And in my opinion, the fuzziness, the uncertainty of a setting also plays a role in that, because some of these gut decisions, we don't even know why we specifically make this particular decision, but somewhere in our unconscious mind, we probably have some sort of information that, points us to a certain direction. And as we heard, like AI, ML, they are based on data, right? So if the data that we feed those AI, ML models does not necessarily capture everything that might impact the planning, that might impact the budgeting, it might also lead to, trust issues or worse predictions overall.
And what is your your idea, because the second question was really interesting. What is your idea about having a third opinion, so having another AI opinion on something? I mean, that sounds quite smart. I mean, if I don't trust one AI, why not use another kind of AI for a different opinion?
That has failed miserably in practice. If we're looking at, say, Microsoft Tay, when you have bots botting at each other, picking up bad language off of each other, it can spiral downwards very quickly. Having an AI monitor an AI when the fundamental problem is, do I even trust an AI, is probably the least good way to go forward. You probably really, and we've seen actually, you want humans in that loop.
Yeah.
Okay.
There are technical solutions, right? So like they're called adversarial networks, that essentially like an AI that tries to poke holes in the other AI and challenge them with, hard to predict observations, etc. But, as Maggie just said, there are potential also really downsides of using AI controlled AIs.
Okay, thank you. So we go on with Carsten's presentation.
Very nice to be here and to have the possibility to show our point of view on using applications of artificial intelligence and machine learning and controlling in finance. This is a new field. I started, I would say, nearly 5 years ago, researching the possibilities and also try to find application areas where we can use it for controlling and finance. And within those 5 years, many tries or many projects we executed to really get into that stuff, but not that much fully fledged. So it's at least a situation where really companies start slowly to generate data, try to work with data, try to come into those new approaches, but use it more as a pilot or as a test field, at least, to gather experience. So in my profession, I'm working for the finance and controlling area since 20 years now. And the main topics is performance management at all, reporting, planning, forecasting, and all that stuff. And I did it really for a lot of companies in different industries. When we started last year with a kind of a strategy process, the question was, okay, how the CFO future will develop and what's the main topics the people have to force on. And CFO future is at least manual tasks will not appear in future as it is today. Because the pressure of the peer group is too high to optimize and really to get manual workload out of the processes. The future will show at least the corporate performance management, which increase enterprise value by leading edge CPM, showing all the data, all the necessary capabilities of reporting, analysis. But we need less people for that, at least, because all the data is automated and provided in data pools over the company, gained out of or feeded by the full value chain of supply chain, sales, production, and everything. And also using external data within their data pools, which are potentially cloud-based. Another point will be that AI and rules transform source data into gold nuggets for finance. When we work as we do it today with Excel sheets, gathering the data from the whole company, we will be far behind the efficiency that we need to gain in the finance area. So from that point, we need to investigate at least artificial intelligence and to use it also for the finance area to achieve our efficiency targets for the finance services that we offer as a finance community. So overall, our observation is currently many companies they're doing other homework instead of using artificial intelligence in finance and controlling, because within their landscape means the data, the systems, and also the provision of data, there's a lot of stuff to do. In general, it's still to be seen as restrained. So it's not very progressive to use AI in the finance area. Only a few companies took the first step and they provide budget at least to investigate some areas where they could use artificial intelligence, for example, to try to make a cash forecasting or something like that, where not that much people are tackled. All in those areas where you, for example, sales forecasting for a human-driven sales organization, there is in high pressure and there's a lot of personal experience within the processes. To start with something like that might occur into a situation where the people are really arguing against artificial intelligence. So it's I would say, high emotional area, and you have to take care if you bringing AI into high emotional areas within a company, like sales development and stuff like that, then this will be one of the hard tasks. Yeah. The further also the investment risk gains and whether the benefits can be achieved often plays the main role. The people don't trust that AI will really lift benefits or gain benefits for the processes. And that's, at least, I would say, we have a conservative way of investing into systems. Everyone wants to be clear, oh, that is the benefit that I can achieve. But within the AI area, you have to, at least to be agile, you have to try it, to test it, to develop it. And that's not the way of working within the finance organizations in the past. So there we need to really change the way how we investigating new methods and new potentials, at least. And the last point is at least the uncertainty about how human and AI will interact within processes, as we already mentioned, within the budgeting or finance area. If you have today a budget process, strong negotiation for 1 year, and I would say it's not the right way to make budgets for 1 year, because that's an old approach. And I think the future requires another point of view regarding the future developments. I would skip 1 year, point of views and stuff like that, and go more in a constantly forecasting process, including AI and machine learning technology. Yeah. But there is an uncertainty how to interact between humans and the finance machines, at least. When we are looking for what's currently the topics companies mostly do, this is a kind of CPM framework. They're looking for what is our steering approach, and the point is it's not a situation that you have one steering approach and that will fit into the future completely. You have constantly to rework it and think, okay, new business model, how can I steer it? Which KPIs do I need? Which data is required for that? There is still a big governance topic within the companies. The flexibility on decentral units and the grade of putting a governance into the group without at least taking all the flexibility out of decentral functions. Steering services, how to provide data. We still have discussions about we cannot provide technical reports to the community or to other functions because they are not able to navigate through the data. And there is a risk how to use reporting. But the point is, steering services should provide at least the data to the functions with a high self-service approach, and showing the data in dashboards, tailored information which is relevant according to their responsibilities and roles. Steering processes, that's also the future point, highly automated, efficient, supported by artificial intelligence to at least gain valuable forward-looking business insights. But there is the point, currently, within our project landscape, we really fight against traditional approaches. We fight against making a negotiated budget over the year and stick to that for 12 months in a time like today. Yeah, seems not to be a feasible way. So we are starting at least bringing the forecast much more into focus. Forecast information much more in the reporting landscape. Technology. The data pools are currently not well organized. We have big SAP ERP programs with S4 implementations and stuff like that to get it more in shape. And also with non-financial data, the companies, they still have to work on how to store and how to provide on a constantly basis data that they need, at least also for machine learning and artificial intelligence. Currently, the time to market for AI solutions is too long and it's too expensive because of the data processing upfront. You have to collect it, you have to rework it, you have to clean it up, and then you use it at least for the modeling. But this process, many companies are still working with Excel, putting the data from one corner into the other, instead of investing in a data strategy that delivers the data pools and to reduce the time to market for data-driven solutions. Yeah. The next 2 points, sourcing, organization, centers of excellence that you need, because you have to incorporate data science knowledge and you have to incorporate the people who are working with that, and to find at least collaboration models between traditional functions and also the new technology. And therefore, you need to upskill also the finance people, that they are at least able to work together with data science and to interpret the black box and the results of any AI machine learning models. Yeah, but at least this is a kind of a target picture that most companies have, and one main benefit is at least it's a much more cost-efficient way to deliver services in the finance area if we reach like this target picture. When we are now looking the CPM framework, which is typically the steering logic with all the different areas of reporting, steering, financial performance, market performance, value chain, functional performance, team performance, according HR and stuff like that. We have the classical processes, set targets, forecasting, close, consolidate, analyze, report, discuss performance. And beyond that, we have all the data landscape, financial data, non-financial data, which is still an area where we need to incorporate more data than it is today, because the financial data is a kind of a silo, represents everything in the value chain. But the non-financial data, to have a comprehensive data warehouse or data landscape that allows also to combine financial and non-financial data, is still an area that we have to work on. And at least the ERP systems, or also the operational systems within production, within supply chain, to connect all the data. And that's currently the area where most companies are still doing the change regarding old ERP systems into a new landscape, which is, for example, SAP HANA, but also other solutions are on the market. When we are now looking for what are AI applications which are available and which are already in use there are certain areas where we have already experience and where already solutions are tackled. For example, within the financial performance, cash and EBIT prediction, taking surprises away. Sales and demand forecast, which is a hard area, because if you, for example, connect sales and demand forecasting together with financial processes, there's also a lack and negotiation and politics behind, because salespeople, they try to get all quantities they need to make their sales, even if it's not realistic, but they have another focus. Then we have cost prediction, stock prediction, working capital management, within the HR area, utilization, personal planning, dropout prediction, all those areas where already applications exist. And maybe sometimes it's a kind of a starting point. They're getting better results than compared to manual processes, but there is still potential for improvement, because in many of those, I would say, artificial intelligence cases, the data which is used, there is still, it's more the own data of the companies. There's still potential to extend and to further develop these models into a wider competence area, or into a wider set of data. Then we have augmented analytics. This is started going forward, out of the box artificial intelligence functions, which are delivered by reporting tools like SAP, SAC, or also Power BI and stuff like that. It's not tailored, and those are mostly quite simple models, but it's a first way to go it. And it's at least less expensive than a tailored model. Then we have big areas of application within planning and forecasting and simulation, taking all that into account, at least within the target setting or within the forecasting, and also partly in the planning area. But as already mentioned, the confidence is not there that the data will be accepted, and that's the reason why the companies do not invest into automated planning by artificial intelligence. One very interesting area is bias analytics. Generate an idea. What is the typical bias that the people will deliver, for example, in planning? It's every time the same thing. The people deliver too much quantities or expecting too much quantities because they want to make sure that all products are available. But from working capital perspective, it's a bias. You need to get quality into that so that you can ensure not at least to coordinate your resources efficiently. Then we have smart master data. Master data is one of the biggest things within the companies, because the job is not very nice to organize and to bring master data into a good shape. There are lots of potentials regarding AI models, really to shape it, to clarify or to bring quality into customer data or into product data and so on. There is a lot of potential. Then we have posting automation. So really automized posting of billings and stuff like that. Anomaly detection in terms of finding exceptions where data seems not to be proper, or there might be a quality issue or even fraud detection. This is also in combination with semantic and market analysis in terms of taking, for example, Twitter data or Facebook data and find out how products run in the market and getting information out of that. Or at least predictive maintenance, also in terms of financial optimization. If you have predictive maintenance, you can also get inputs for your investment planning. So there are a lot of applications available, and at least when we jump through that, revenue and sales prediction, increase reliability, also in terms of demand forecasting. Benefit, high automation. You can at least predict sales revenues. Also, pricing components can be included and stuff like that. And the best potential is at least to use it also for planning and forecasting data. And it's an easy case. In most areas, there's a good fundamental basis available with historical data. We typically use for that sales data at product order level, customer level, depending on the business model at least. And we combine it with external data and also internal planning data, for example, sales expectations from the sales area, at least to gain the revenue and sales prediction. It will pay into target setting, forecast, and prediction, also in reporting and to discuss the performance. So it's a really good instrument, at least to challenge and to bring the quality in the sales area forward. Another area is cost prediction. We did a model where you can at least make a prediction of cost centers, or the total budget of cost centers down to an account level. And what we gained at the end is even for overhead cost centers that we have a higher quality as expected in a manual interface. So therefore, there's a huge automation potential, especially in the overhead area, where you can really automate the creation of plan data. But maybe for a first step, you can use it also to at least challenge the created plans which are delivered by the cost center owners or something like that. Yeah. Typically, we use cost center accounting data for that based on SAP ERP/CO, but every source is at least possible for that. Here's a huge optimization potential. And I think even if you put forecasting more into the focus, this will at least give you the possibility with such a model to make a new forecasting within 1 hour and not gathering data in 6 or 8 weeks from the whole organization. Yeah, this will also pay into set targets and plan, forecast and predict, analyze and report, and also discuss the performance. Next topic is cash prediction. We built up a model, and that's very interesting. You can at least use it also for short-term optimization. You can look at certain customers, identify, okay, are they typically late payers? Do I need the money on my bank accounts? So I start at least with personal interaction to get the money and to start at least the management of your receivables. Fully automated, done within minutes, using all the cash-related data, the incoming orders and stuff like that, accounts receivable, sales data, and posting level. And then you have automatically the possibility to jump into that, to see the potential cash in of next days, even months, and can also investigate it down to invoices or down to customer level or whatever. There's a huge potential, at least, really to get the receivables management into a better shape. Next topic, EBIT prediction. Reduce surprises, automated. We did it for a lot of companies. There are different possibilities, at least, to create a model like that. One is really to make a prediction on the EBIT KPI. This is a kind of a black box. Nobody knows at least which components the EBIT results. Is it a cost change, or is it at least a sales change, or any other impacts that will come into that? But it helps very much, at least, to use it as a kind of a flash forecasting in those months where you do not facilitate in full organizational involvement within the forecasting process. And you can use the financial data for that to make a group-wide EBIT prediction. Another way is you can also make a prediction on the components of the EBIT. That will also drive the possibility to make it more speakable, understandable, and you can also use it at least to describe more or less where is it a price volume mix situation and where the changes come from. Yeah, but EBIT prediction, some of our clients use it at least to see, okay, we did the forecasting with our companies and we did in parallel an EBIT prediction, at least to see if the manual processes fits into the same expectation and to learn from each other. Maybe on a second step, the EBIT prediction can be a part of a full automized planning approach. The next topic is at least, for example, tax analytics. You can use all the company data to monitor and at least to detect possibilities to optimize your tax efforts or tax burden that you have to pay. At least there are different possibilities. You use accounts receivables, payables, general ledger data on document level, and then you can gain or find potentials. This is at least you can use it for forecasting, at least also to collect for planning and forecasting purposes the tax that you need to have to pay, and also at least to increase quality and close and consolidate and taking measures to reduce the tax burden. So this is a quite new field where we really find or look for possibilities where we can take action to reduce at least the taxes to be paid. And there is one other very interesting area, which is in the area of anomaly detection. We take all the financial data from all companies and subsidiaries. And this is at least belongs to closing and consolidation, and also analyze and report, discuss performance, also in terms of discuss mistakes within the data and stuff like that, where we take all the financial data and observe if there are any postings available which seems to be a kind of fraud or mistake or something like that. And upfront, the closing processes really to investigate, discuss with the right people, and find out if there is really a mistake or which can be corrected upfront the closing periods. This is a very powerful possibility, at least, to gain also or to increase data quality in finance at all, and also to have the possibility to generally observe fraud detection and stuff like that within a whole group. So we used, at least for that, group reporting data, which is more on the group level, company level, plus additional data from local ERP systems, all the general ledger data, at least to observe if there are any potentially any situations within the data which are not normal, which are untypically, and we need for that we use the Banish model. Yeah, this is a very interesting application, at least if you have typically different ERP systems in place and identified in the past already higher issues in the quality of the posting data. What are at least the key benefits? Artificial intelligence in controlling and finance really significantly increase the automation. You will have you gain business insights, because every time when you work with data, when you try to use artificial intelligence, there is a creative process, and every time there will be insights that you get out of it. Maybe not the ones that you're looking for, but it's very interesting, at least, to work with data. You have human bias reduction. For sure, there is also machine bias, but you can also use the results of the model, at least to challenge and to questioning the data which is delivered by your subsidiaries or even from your organization. And frankly spoken, a very high accuracy. In most cases, we were really able, with small data sets already, to have a better forecasting compared to what a company is delivering in manual ways. And above all, faster information and sufficient quality. That's the key fact. And from an overall CFO landscape perspective, this will be in the next 5 to 10 years the main topic, to get information faster with lower manual effort. Yeah, and I'm completely convinced artificial intelligence will deliver all these possibilities in a sufficient quality. One really important factor is, it's not the point to put a machine in place and then just work with that, and the human opinion is not longer, or the human being opinion is not longer relevant. I think you need the power and the competence of the people, at least their business experience, to identify possible patterns or to identify relationships. And they will also be able to at least investigate the results of an artificial intelligence and to bring it at least to the people. That means to gain out the data that you need for decision making to steer the organization towards target achievement. But the human role is still very important. There are some areas where you can just work with machine learning, to understand the data and also to take action based on that. But especially in the planning area, planning and forecasting, a human judgment is still possible. Machine learning is much more capable in terms of gathering and processing large data amounts and gaining something out of that which is with a high quality. Yeah, but humans can judge, humans can explain, and humans can also identify new areas of application, and therefore we need their intelligence and also their experience. When we are looking for what are at least the requirements or success factors to apply artificial intelligence in finance, the first one is trust AI. If you work with artificial intelligence and you analyze and dealing with companies' data, it always brings benefits. Maybe not the one that you're looking for, but it always brings benefits. We need to create competence, the new normal, to work with data in a structured way, and not the way of how Excel sheets going through the organization. It is very important to jump into that topic. The second point is reawake explorer mentality. Progress needs people in finance who deal with the potential. And unfortunately, we are often sticking too much into the habits and the way of working as we did it in the past. We really have to explore how it works and how we can gain benefits out of that. And this will not work if we don't get the first steps into some certain cases or stuff like that. Third point is at least digitize the data. Otherwise, the time to market is too long to inspire and engage. Work on your data pools, work on your data landscape, acquire data, find ways to store it on a company basis so that you are able to connect, to use, and to provide it fast and in an efficient way. Be agile. Allow at least to make mistakes, run through that process, try it, find new ways, try to engage the people to check, to make proof of concepts. It's part of the game not to know the result upfront. You start into artificial intelligence developments. So really, there is an agile approach needed. Yeah, it's not expected if you do a proof of concept that you will gain out of it what you expect in the beginning. It will be really an exploration. Think visually. It's necessary to communicate results in a way that can be understood. Reporting is really the key. A good dashboarding to explain at least results of an AI model. Otherwise, the trust will win, or the confidence is not given. So the way how to present the data, at least to the board or even to the stakeholders, is at least a key to convince the people that artificial intelligence is a trustful method to bring finance and controlling forward. And at least the last point that I want to raise, secure funding to advance in AI and finance. From my point of view, there is too much skepsis available. The people are not spending money into that. They are arguing that they don't believe the benefits will fit to the costs. It is too important for the future to gain the efficiencies or to raise or lift the efficiencies for the companies. You need to focus on artificial intelligence. That's the technology, at least, to drive finance into a high efficient landscape in future. And I think this will be the main point. So thanks very much. Hopefully I gave you a short introduction, different application areas, and open for questions.
Thank you very much. I think there were so many new insights. I don't want to wrap up. I just have one question, whether I understood on a very general level it correctly. So in a way, as far as I understood, there are maybe two ways how we can use artificial intelligence. One is to detect patterns that we otherwise would not detect. I mean, in a way, like fraud detection is a very obvious example. And here we do not have a trust problem, because then we can go deeper with our traditional methods anyway, and we can find out if that what the machine proposes is correct, or if we really find that, right? It's just helping us, right? Helping us to find patterns that we otherwise would not find, right? And the other thing is, in many areas, it's just you see it as a support of our own decision making. So that what the artificial intelligence proposes is just to challenge what we do, and maybe like in sort of forecasting models where we know that there are some obvious biases and also maybe strategic ways of manipulating data or whatever, or seeing the world as we would like to see it, or whatever the human biases. And here artificial intelligence is just here to challenge your views and have a second opinion, and then it's a process, as you told us. I mean, from the more and more you find that what the machine suggests is not so bad always, the more you can generate the trust, and you can. It's more or less a tool to challenge your own view and to learn. I mean, it's not just because in the beginning I thought, okay, if the machine learns, do we learn then, right? Is the machine doing the learning, and we don't understand, after all, our data even less than before. But this is very optimistic view, because it helps our own learning processes, right?
Definitely. Yeah, definitely. And, the starting point is at least to have a second opinion. Yeah. And to use it and to gain experience. And then we can convince people using it, and also, I would say, hand over work to AI models in terms of, okay, the quality is sufficient. It doesn't make any sense that we work with 20 people for 1 week to gain the same results. So let's do it in an automated way. And as I already mentioned, the CFO area will be under pressure because the peers of all the other C-levels, they make Internet of Things, bringing the production into shape with automation, whatever. Also the finance area, we cannot work with 150 Excel sheets in 2030, to gain a plan which is at least in the quality insufficient. So there must be new models. And I think a starting point, second opinion, and then if you gain trust and going forward with that, you can convince people to accept. With a supervised learning, for example, with the possibility to interact and to bring their own point of views, and not make a closed box out of that.
Mm-hmm. And do you have a recommendation where we should start in the finance function? I mean, as you saw from our poll, it's many do not already have it. So if you want to, start this process of building trust and where should what would you say? Where should companies start in the finance function?
Frankly spoken, there's we did one project with a client who is a mid-sized company, and one starting point was they did a quarterly forecasting, and we introduced a flash forecasting, which is on a monthly basis, delivering at least questions or delivering results that you can use in the quarterly forecast to evaluate the quality again. This is a kind of an approach which is a additional steering instrument at the end, providing also a clear view on potential developments and gaps that you can also use for a quarterly forecast to at least discuss performance and results, and then with more quality and also with another second opinion in mind. So that's a good way. But overall, I think planning and forecasting, I did it since 20 years, and it's still pain in the ass, frankly spoken. Many people are engaged, last sometimes 3 to 6 months. And at the end, it's all data, because the process is too long, at least to be really in shape when you're ready with that. And there are so many areas where it's not worth to put so many people into the process, so that you can investigate, for example, overhead planning. Unfortunately, it's a political topic, but it not relies too much on sales developments and stuff like that. It's a good way to try really to make cost center forecasting or something like that with AI support, and to automate the generation of figures, of planning figures for that.
Mm-hmm. I mean, of course, this very much speaks to what you said. Of course, it's both is too extreme. I mean, AI will not always bring benefits, and it's not always just costly. I mean, it's very difficult, as you said, to assess what are the benefits and are they really more than a cost, because exactly of what you just said before, it's a process, and in the beginning it's difficult to assess what really the benefits are, right? And what you said, that you can use it instead of teams of I don't know how many people, and where it really saves you costs, that is definitely not in the beginning of this process, right?
That's right. The always brings benefits is also a topic of, we have to learn to work with data, and not with Excel sheets. And therefore the process to jump into that topics and to investigate and to find out what you can do and whatever will also train the people towards modern technology in the future. And the benefit is also that you are jumping into those topics, that you learn to think about data structures, the potential of data, and not in the old traditional way with Excel sheets and stuff like that. So also the other point is when we did AI ML stuff, there's also an insight that you gain, even if it's not the one that you're looking for. And there are a lot of surprises within the data if you use company data, for example, to investigate a certain topic. And I think many of those topics, or in the most areas, we still get benefit out of that. But you have to be open, which might be the benefit that you can earn at the end. Yeah.
And as far as I understood, you say, all of you said that this is a trend that will really increase and come anyway, and it's better to start already to get some skills and working with those methods, and not to wait until you don't have a choice. It's like in many other cases, right? That's right. Okay. So thank you very much. Thank you also for discussion, and I think that was very, very interesting insights, both from the research point of view and from the practical point of view. Thank you so much. Thank you for acting as speakers and contributing. Of course, I also use the opportunity to thank all the staff behind from the Controller Institut, Jasmin Pamminger and also Karin Zemanek from our side. I think the whole conference was a great success, and today the thought bridge for me is always very, very inspiring, and I can only end with the idea which I used for opening this thought bridge, call for collaboration. So all of the managers who are interested in such topics, and please contact us. You can contact me directly or whomever you contact. We are happy about any insight, even if you complain about our students. I hope you don't do that, but if you tell us something what we did not provide them with, and you say, well, they don't know what an EBIT is or whatever, then tell us as soon as possible, and we will fix that. And and again, if you have data, or if you have something you wondering, if you detect something by using artificial intelligence and you don't understand the data, we are the experts for data, and just contact us, and we are happy to have a look at your data. And okay, so thank you everybody again. And if there is still questions, you can still use the chat and or just email us. And I think also Carsten Bork will be happy if receive emails, and
definitely
all the others, I guess. Thank you again.
Thanks very much.
Bye bye. Bye bye.
Thank you.
Bye bye.
Thank you.